Oh, back at you at Super Micro. So we've completed the first two vignettes that talked about basically PodView registration and collecting monitoring detail or sensor detail from out-of-band management through Redfish subscription services. We showed you some of the message event log information, session event log information, and also sensor telemetry that we can collect from the server itself. So what's next? What do we do next with our lifecycle management of what we can look at and expose within our server platform? And that is really, we're going to move into really the next important lifecycle management at a server level. And that becomes extremely important because that's a hallmark of basically server management is providing those buttons on the top to perform or manipulate different things about a server, right? Such as updating the firmware or resetting the BMC or providing tag management or deploying an operating system or collecting various metadata, data mining of components that are inside that server for forecast planning. So many, many things that are going to open up here for standard lifecycle management at a server level. So I'm going to show you how you can easily search the platform itself, right? So let's start by really looking at the search filter we put out here. And this is nothing different. We've talked about this in previous podcasts where we build an element table of compute list information or system list information. And we expose various different attributes. That those attributes we collected through Redfish, and we build a customized table for you that you can customize yourself by looking at various different attributes of the server in minimizing your search. So let's say you had again 20,000 monitored hosts, and I wanted to look at data specifically. Show me all the servers that have I don't know, maybe perhaps a 2-core socket server, or show me all the servers that are from the product family, GPU family, or show me all the information associated with the microcloud family, or Ultra family, or Hyper family, or DC Cloud, or Blade family, right? For that matter. Show me the memory size. Maybe I want to look at specific information. Show me all the servers that have a RAID card in them or have been deployed through an operating system such as Rocky Linux or potentially CentOS or RHEL, right? So all of this information at a glance is you're able to search a large search list of 20,000 monitored hosts that SuperCloud Composer can scale to and be able to look at specific metadata. So maybe I want to take that information and maybe I want to go ahead and dump those component attributes into a CSV, a JSON or YAML file. And maybe I want to do forecast planning of my environment. I want to know or get an understanding of what components are in a server, right? And be able to perhaps import that into an Excel spreadsheet, build pivot tables, and look at specific information about each of my appliances that I have in my data center. So that becomes extremely useful for a DevOps administrator to do forecast planning and being able to do data mining within SuperCloud Composer. So all the basic lifecycle management icons are available. This is nothing new. We've talked about this in previous podcasts, whether it's an air-cooled server, whether it's a liquid-cooled server, all of this information is available to you, whether it's a Grace Hopper system using NVIDIA, or whether it is a AMD MI300 GPU server, or whether it's an Intel-based Gaudi Habana system. All of this data is available. So this is the only platform in the industry that exposes all of the semiconductor vendors out there for use cases of AMD, Intel, and NVIDIA. and various different platforms, collecting this information for an NVL72 use case. We talked about that of our supercluster AI in a previous podcast, or we talked about managing Blackwell compute, right? The B200 use case, and soon other accelerators will follow that NVIDIA is basically announced and what we're cooking in the background with our hardware system PM teams. So it's important, again, to provide lifecycle management to be able to provide a high level view of how these particular systems are operating in your data center. And I talked about this in a previous podcast. If you jump in your car and you're going from, say, where I am here in Arizona, I'm in the Tucson area, to Phoenix, and I went ahead and decided to get in my car and drive to Phoenix because I wanted to see a friend up there. And do you get into your car and just drive, right? Pretty much so, right? But I can't imagine if the car didn't have any instrumentation there to indicate whether I ran out of gas, right? I need to know, do I have a full tank of gas to go from Tucson to Phoenix? Because it's now the summertime and we're in 100-degree temperatures, I don't want my car to overheat. I want to be able to make sure that that car is accurately depicting the temperature of the engine, right? And I want to be able to have an indicator there to let me know that I don't burn out the engine, right? Or maybe there's one of those police officers sitting on the highway there and they're clocking me in my radar, and I want to be able to maintain the mileage or the speed limit, right? I don't want to go over the speed limit and then end up having to be ticketed by a police officer, right? So I want to have an idea how fast I'm going, right? And not only for safety reasons, obviously, so I don't get ticketed and I obey the law. So I can't imagine you wouldn't have a system in place, which is an enterprise management system to monitor and manage and alert on anomalies that exist within your data center. It becomes very, very important. Um, and so that's something we need to have oversight on. We need to have observability within our data center to determine how well our data center is performing and how well our particular systems performing specifically about workloads, right? All right. So rambled a little bit there and got off a little off topic, but just wanted to zone in on the point what I'm trying to make of why lifecycle manage is important to an enterprise. So we're going to plug in the IP address. I just happen to know it here. And you can easily search within your environment here, right, by an IP address. So remember here, we talked about 200.200.1.155 as the server that we want to look at. And if you click here, you can easily see here the physical asset collateral information. This is going to be vital, right? The product serial number, the product SKU information, the chassis serial number, the chassis part number, and then also the physical location of where that is, what rack that is associated with. Obviously, a front and rear view we show here, and then other metadata that we've collected associated with this server. And then on the top here, we break down the system list. We filtered it here for you, and you can see here discovery state is basic here because we essentially discovered it. It's now registered within our rack configuration of PodView, and then other various columns here that we basically provide to you within this particular platform. So we're just putting the final touches on this particular validation process, but I thought I'd give you a sneak preview of what we have here within the MI325 use case. The nomenclature on the end here, LLC, designates the fact it is a liquid-cooled server. And then you see the power state of on. The node ID would be when we compose or deploy an operating system. The health rollup again, right, that we see here. It's a 2-socket, and so on and so forth. So you can easily basically look at this data and information available to you. Now, I want to look at what's inside this server. What are the components that are inside this server? And so I would then click on what we call the navigation view here. But before we get into the navigation view, I want to just hover over each of these items here or icons to show you rich lifecycle management for this server that you can perform with any server, any semiconductor vendor, whether it be AMD, Intel, NVIDIA, right? Any servers that are part of the Supermicro product suite, and we can and also do third-party device support for our friends across the aisle, such as Dell, HP, and folks that are adhering to the Redfish DMTF standard because our agent's been built in to collect that metadata, which will be important. So in data centers, you may not have one vendor, right? You may have multi-vendors, and customers are interested in providing a unified dashboard experience to manage their entire data center, whether it be third-party device support or whether it be different types of servers that exist and different CPU chips or different types of servers or model types that exist within their data center. So that becomes very, very important. So I'm not going to go into detail of each one of these because a previous podcast we went into this detail, but I just wanted to show you that this flexibility is offered within any platform that gets managed and monitored within SuperCloud Composer. So all of these buttons here become key for you to perform lifecycle management associated with this server, including firmware updates, connecting into the IKVM console or the BMC, and then detailed information about the server, and so on and so forth, and the ability to dump components, like I mentioned before, for this particular server. So if you just want to look at dump information about the server, remember you're doing a search related to product family GPUs, and maybe it's this product SKU, and you have a large AI factory that's deployed with liquid cooled servers, and you want to get an idea of each of those servers, right? All the AMD servers that you want to, and where they're physically located within your data center and which racks they're associated with. And then you want to build maybe perhaps a table or some type of uh, charting associated with the environment, right? That you're looking at, right? As far as servers are concerned. All right. So the next thing we're going to do here is click on this one here. And this is going to open up a lot more information that we show up within this particular AMD Instinct platform. And we still continued passing on all of your lifecycle management buttons, so you don't have to navigate back to the previous screen. We provide all this information. And I wanted to point out here, well, why are these grayed out? Why are they grayed out? Is because this is reporting a health roll-up of critical. So based on that, we have checks and balances in place based on compliance and governance, right? Which is important to a data center. So we don't want to deploy an operating system to a server that's already exhibiting poor health or that already has an operating system allocated to it, or be able to manipulate the DMI or FRU because you already have that system in service, right? So we basically do the hard work for you of putting checks and balances in there, of allowing you not to go ahead and perform such task activity for lifecycle management until you rectify the server and figure out or mitigate what the problem is, or you deallocate the server and not be part of the pool, so on and so forth, right? So there are all kinds of different use cases around how we implement compliance and governance, which becomes an important aspect of your data center. And then you can see here the physical asset collection that we provide here, the BMC address. You can click here by clicking directly into the BMC if you need to do that. You can also deploy an operating system from the screen using common PXE service. We have two forms of deployment. We could deploy based on a standard Pixie service, or we could use fast deploy, which is similar to Metal as a service, where we inject metadata into the build because you have some type of SLA that you want to deploy the server within seconds. And so that uses our storage pool backend for an iSCSI target and also initiator. But we won't get into those details. We're just talking about very specific information about just monitoring, managing, and alerting, right, for MI300. We provide, again, the memory information on the top, right, as far as the carousel view in this screen. So we've continued to provide you that information within here. And then you also see on the left-hand side a side card that shows you information. So you can look at analytics, system, processor information, memory, all of the sensor data that's provided, out-of-band management. So not specifically workloads that are running on this server, just basically bare metal sensor data, right, that we're basically reading from Redfish subscription services for out-of-band. And then we can look at all the detailed attributes that are part of this server, components, the size of memory, so on and so forth. So you can see here we have a 384 core installed on there, two NUMA regions, basically the CPU1 and CPU2. So it's a two-socket server. You can look at memory information here. And you can look at it per NUMA region, right? So we show both NUMA region 1, which is associated with CPU2, and NUMA region 1 associated with CPU1. And then we show detailed information about part numbers, the slot information, and then the type of manufacturer that we have. We have a device type of DDR5 as a DIMM, and then we show memory and show good standing, right? So all of this information is monitored, remember? So if you're getting ECC errors or you have a particular a memory go out, that'll be reported in Redfish, right? And it'll tell you that that DIMM is incorrect. So we identify where that DIMM location is based on serial number and the DIMM that's affected. So in some particular use cases, that might be important, right? From an environment maybe such as a classified SCIF, where you want to be able to make sure that nobody inserts a different DIMM than what you're usually seeing, right? Because that could be a security vulnerability, right? So we want to be able to track part numbers and serial numbers, which are going to be very, very important, especially in a classified use case or classified SCIF, right? So we provide all this information to you. Local storage information, simplified storage. We show you here we have a Broadcom SAS 3808 in here. And then if you needed to do any type of storage controller type stuff, right? If you had specifically an opportunity to configure the storage controller itself, right? We would provide that information, then you can go in and configure RAID, right, appropriately, right? But in this particular use case, this doesn't support RAID. But if you had a RAID control, an LSI RAID controller in there, we could do basically RAID from RAID 0 to RAID 60 if that's a use case that you need to perform within your environment. And then it would show you all the types of RAID that are available to you. But in this case, it's an NVMe drive, right? It's not a SAS or SATA drive itself, right? So we have a SAS or SATA drive, but we have NVMe drives inside, right? So shows you the model number itself, health, status indicator, so on and so forth. So you can read it here. Table is very rich in detail, showing you capacity of each drive, and then the capable speed of each drive and the temperature. And by the way, you can monitor and manage these drives too as well, which would be available within monitoring detail, right? That I didn't touch on earlier, right? So that monitoring detail, you would come up here and you'd be able to chart the drive status and also the drive temperature of a specific server, right? So that becomes important, right? When you're doing any type of monitoring and management support for this server. And then we can go down and look at other information. Let's drill down to the NIC here. And you can see here where we expose very important information. Link status, very, very important. And you can see here, we provide the link state, the MAC address. All of this information is available to you at your fingertips to easily take a look at ones that are up and operational. And we color code it on the bottom here to indicate that it's green, right? The rest of them are showing as gray, indicating they're a down status. So if you're troubleshooting a network connectivity issue, and you could start at the server level, and maybe your network switch guy says, that's not my problem. It's not my problem on the switch. That's your problem. That's your server problem, right? We want to break down those barriers and be able to help you isolate where the problem is, right? And you could start here by looking at your server. And then we can also look at GPU information. So lo and behold, this is an MI325. It truly is, because we see all the 8 GPUs installed within this server, showing you basically the lanes, the health, and the PCIe type. And this is a direct-to-chip type of environment for GPU, right? So this is where the liquid cooling comes into play with Supermicro, and where we're leading the industry in liquid cooled data centers around the world. Many deployments going on today with SuperCloud Composer. So I'm just gonna not go through the rest of the information. I'll quickly go through FRU and DMI. Again, all this information is provided across all platforms, all semiconductor vendors, Intel, AMD, and also NVIDIA, and also available on the extensive amount of server SKUs within Supermicro, right? We have an extensive amount tailored and customized for your workloads, right? So we provide all that validation and support within SuperCloud Composer. And then the last piece here, we're going to look at DMI, right? And the DMI here shows you other information that you can track. Maybe you have to replace the motherboard, the baseboard, other various things within the server as a field replacement. You can go in here and make those changes appropriately here by just clicking on the edit function and doing so and saving it, right? So no need for SAA, no need for some. All of that is now available to you. So again, we're trying to build on an enterprise solution. You don't want all these disparate tools to be able to utilize within your environment for enterprise customers, right? You want one place where I can control everything. Now, there may be a use case there for specific software vendors out there that they're building their own software IP. And at which point in time, from an ODM perspective of Supermicro, we provide those tools for you necessary for DCMS and so on and so forth to build your own management platform or build your own type of IP specifically to your architecture or your environment, right? So this is, again, something we provide within our platform, which is easy to implement, can scale to 20,000 monitored hosts, and is all there in a unified dashboard experience. So signing off today, that's all I'd like to talk about from a standpoint of lifecycle management. Next time, we'll get into more detail about other things we can expose and look at within SuperCloud Composer. Thanks for joining today. Have a great day. And we'll see you next time.